Hello, in this lecture, we will take a peek at metabolic rate and some factors that affect appetite. So when you hear metabolism or metabolic rate, the basic idea is that the energy that comes in should equal the energy we're putting out, and that if we have the same, then there's a balance and you're not gaining energy or losing too much energy. And when we have energy output, remember we always lose energy as heat. So there's a lot of heat that's lost every time our bodies generate ATP. And so when we look at metabolism, this is kind of the older model, calories in, calories out. And the basic idea was if you measure the amount of calories you eat. If you take in more than you use, your body stores that excess food as fat in your adipose tissue. And if your daily calories exceed, right, so your expenditures, if you're burning more calories than you're taking in, then you're going to use up your reserves and you're going to lose weight. And this is what the thought was for a long time, but we know this isn't actually true anymore because not all calories are equal. We know that what you eat and the source of the calories really does affect how it's metabolized by the body. We know that when we eat more protein, it actually uses more energy to break it down versus simple sugars, which are quickly metabolized. And so it's not just the number of calories, but it's the source. We also know that the timing matters. Intermittent fasting is a tool that's done. There's a couple ways that it's done. Some individuals will have a 500 calorie a day fast one day, and then the next day they eat normally and they alternate. While others might just have a certain window, like maybe you only eat from 12 p.m. to 6 p.m., but you can eat whatever you want. And so there's been a lot of success with the intermittent fasting. I'm not sure if anyone knows exactly why, but it seems to also work. So it's not as simple as just what you eat and the number of calories that comes in and the calories that you burn. So you really want to look at the source. We know that our basal metabolic rate is basically just the minimum amount of energy you need to survive and function. You can see what those, ATP production, how it's used. You would just be awake and alert. You can't be asleep. In a normal room, you're not shivering or sweating. And so they can actually measure this. And what they actually measure is your oxygen consumption. Because remember, the ATP take in oxygen, the mitochondria take in oxygen to produce ATP. And so they can measure that and they can estimate your basal metabolic rate. It's usually somewhere between 1,000 to 1,200 calories per day. And again, it's just to run all the sodium potassium pumps, generate the ATP for your cells to function. Now, what we really want to know is, what could change that? So the biggest factor actually is your body's surface area. How big of a person are you? If you're a really tall person, you have a higher surface area than if you're smaller. So think about it as how much of your body is exposed to the elements, because this causes you to lose a lot of heat from your body. Thyroxine is T4, the hormone from your thyroid gland, and we know that also determines your metabolic rate. Age, we know that it decreases with aging, probably due to a piece of muscle mass. We know that muscle tissue burns a lot more calories. It's estimated that muscle, like a pound of muscle, would burn 70 times more calories than a pound of fat. Just the muscle cells are more active. So if you have more lean body mass, higher muscle mass, you will have a higher BMR. You can calculate it. I'm not making you do this, but if you're curious, there's a formula to calculate it. If you can't get yourself, they're called a bod pod, and there's different tools that can actually measure this for you, but you could roughly calculate it. Now, your TMR is probably what matters most. This is everything that you do during the day with your BMR. So this is why we exercise, because we know that exercise, not only do you burn calories when you're exercising, but when you're not, you have a higher metabolism. So they call it your NEAT, your basically non-exercising. You're looking at your burn in your muscles. So when you exercise, your metabolic rate is actually higher for about 24 hours later. So when you're not exercising, thermogenesis just means that you're producing more heat, that your metabolism is higher. And so that will go up. So if you exercise daily, then you're actually giving yourself little spikes of metabolism, a burst of metabolism that lasts the next day as well. The other thing we know is eating burns calories, and this is what I was referring to earlier. We know that if we eat a lot more protein, it takes more ATP to break it down than lipids or carbs. And so it's called dietary thermogenesis, and it's just the increase in metabolic rate when you eat. Because remember, you need peristalsis, the digestive system has to work, you have to move all those electrolytes and nutrients, and you don't need all the specific details here, but just know that when we eat, we do get a spike in metabolism, and it does depend on what we're eating. So basic idea here, what controls appetite? A little bit on nutrient signals. We'll talk about chemical signals, body temperature, and just kind of gloss over the psychological factors. So we know, first of all, nutrient signals. We're going to be looking at nutrients and also a bunch of hormones. You've heard of leptin and ghrelin before. We've talked about insulin, but we know, remember, that insulin is released anytime we have an increase in our blood glucose levels. So when we eat a meal and our blood glucose levels go up, that will trigger the release of insulin. And one thing insulin will do is go to the brain and help you feel full. Whereas if we don't eat and our blood glucose levels fall, you might remember that we will release the hormone glucagon. And glucagon will also go to the brain, and it will trigger a sensation of being hungry. Now, the hormones, insulin and glucagon, again, can affect the brain, and they're mainly doing this because of the nutrient levels. If we're looking at our blood glucose levels. Also know that having higher fats in your blood when you eat, so if your lipids go up, it will make you feel full, and if they go down, then you'll feel hungry. We know that there's some neurotransmitters, so we'll come back to leptin and ghrelin shortly. The neurotransmitters are called ghrelin and neuropeptide Y. Ghrelin is going to make you crave fat and salt, and it increases appetite. So they kind of think ghrelin might be that missing link. If you've gone out and you've had alcohol, you might notice that you eat more when you're drinking, and they think it has to do with ghrelin, because if ghrelin goes up, you're going to crave fatty food and salty food. And ghrelin levels typically go up in the evening, so you might crave more of those foods at night. Whereas neuropeptide Y is going to make you crave carbs. And stress can increase levels of neuropeptide Y, and it also goes up in the morning. Now, just a real quick review. Remember that it's the hypothalamus that is your appetite center. So these neurotransmitters are affecting neurons in your hypothalamus. When we look at the hormones, we'll come back here, we know we have ghrelin and leptin, and they're antagonistic hormones. So we'll do these two first quick. Ghrelin comes from the stomach, and leptin comes from adipose tissue, from your fat cells. And so when we look at ghrelin's nickname is the dieter's worst nightmare, because its trigger is when you haven't eaten. So if you've ever gone without a meal and your stomach growls, think about your growls are releasing ghrelin, and you start to get really, really hungry. And then you are going to probably overeat, because if you eat really, really quickly, it can take a little while before that food hits your stomach, and your stomach lets your brain know, hey, I'm good now. So it's also important to try to eat a little slower. Whereas leptin, on the other hand, comes from the fat cells, and leptin's going to cause you to burn fat and feel full. So when we're looking at these two, they're opposite hormones here. So let me jump to amylin really quick, because I see that's first in your notes. Amylin comes from the pancreas, and it's going to make you feel full. There's been a lot of research in obesity to try to figure out what is going on, because we know that if one of your parents is obese, you have a 40% chance of being obese. And if both are, it goes up to 80%. So clearly there's something more going on. There's something going on biochemically. So amylin will make you feel full. And obese individuals had normal amylin, so they think maybe there's a receptor issue. We mentioned ghrelin, so when we don't eat, when you diet or you restrict your food intake, you release ghrelin. Well, ghrelin is going to make you feel really, really hungry, and so you might overeat. So this is an idea behind grazing and eating small meals more frequently, because it helps keep your ghrelin levels a little lower. Whereas leptin is going to come from the fat cells. Leptin is what you want. It's going to cause you to burn fat and make you feel full. So they looked at this in obese individuals and found that they had normal leptin levels. So now the research is focusing more on possibly the receptors not responding. And we know that sleep affects these. So the magic number is 8 hours of continuous sleep. And if you're not getting that, we know the next day you're going to have a higher level of ghrelin and lower leptin. So you're more likely to overeat when you're tired and if you're not getting enough sleep. Now, CCK we mentioned, and CCK, remember, is triggered by secretions in the duodenum. When they hit that, it's going to tell the pancreas to make that enzyme-rich juice, but it also goes to your brain and helps you feel full. So it makes sense because food's in the duodenum when it's released. We know that cortisol can increase levels of neuropeptide Y, and cortisol, remember, is the stress hormone. So when we are stressed, we release a lot more cortisol, and that does two things. One, it increases neuropeptide Y, so you're probably going to crave some carbohydrate-rich foods. Maybe you notice when you're studying or stressed. The other thing cortisol does is it raises your blood glucose levels, and anytime your blood glucose levels go up, you always release insulin, and we'll come back to that shortly. Estrogen. Now, estrogen usually peaks twice in a female cycle, kind of right before ovulation, and then it's going to be high and it'll drop right before you get your period. And estrogen, we know, is going to stimulate ghrelin. And ghrelin is the one that makes you crave fat. So you might crave more fatty foods, chocolate, etc. at certain times in your cycle. So when we look at this insulin model, this is probably the better model for body weight. So instead of the calories in, calories out, now they're starting to look more at, not only what we eat and when we eat, but coming down to these hormones. And so we know that insulin is anabolic. Insulin's job is to cause you to store glycogen and store fat. So it's going to be really good at lipogenesis. And we know that obesity is probably due to having too much insulin so that you're storing fat and you can't burn it. So you're exercising, you're watching what you eat, and you can't get rid of the belly fat. You can't lose the fat. It's most likely something to do with insulin. So we know that insulin lowers your blood glucose levels. And what happens is you can start to feel hungry again when those drop. And so they're looking at this hypothesis of your carbs, your insulin, your obesity. So you eat the carbs, and again, let's assume they're simple carbs. Your blood glucose level goes up, you release insulin. Often you have too much insulin release, so you get this big surge in insulin. So now your blood glucose levels come down, but insulin's almost like in hyperdrive, so then it's going to take those glucose and it's going to be really good at converting them into fat and storing them. And so what happens is we get into the cycle of insulin resistance, and a lot of it's due to stress. So we said that stress raises cortisol. Cortisol raises blood glucose. That's how it increases insulin. So your blood glucose levels go up, you get the insulin surge, and then imagine if you're constantly stressed. So we'll use the blue to be my blood glucose level. So let's say that you're stressed. So your glucose levels are spiking throughout the day. You get behind a slow driver, you get to school, maybe you're not eating so great either. So we're getting these glucose surges. But what happens is you get an insulin surge. And then you eat again, right? Or you get stressed again. So notice the insulin never really drops back down because you're either not eating well, so your glucose levels don't have a chance to really fall before you eat again, or you're suffering from too much stress. And so what happens is now your cells are always exposed to insulin and they just start to ignore it. It's like if you have kids or you have a mother, if you've ever been nagged, right? Like pick up your socks, pick up your socks, pick up your socks. Well, you start to tune them out. And so the cells tune it out and we have insulin resistance. So now what happens is those cells are not taking glucose in, they're ignoring insulin. Well, where does all that extra glucose go? Well, you might remember it's all going to head over to the liver. And so all that excess is going to go to the liver, and the liver is going to store it as fat. And so we store more and more fat because our cells aren't listening. They can't respond to insulin. And so this leads to something called metabolic syndrome, which is going up. So we do know that insulin resistance is a factor here. So hopefully you're like, well, how do I not get insulin resistance? Or I'm pretty sure I have it. How do I get rid of it? Well, we know that exercise is critical. You don't have to run a marathon. Be more active during your day. Do more things. So aerobic exercise is helpful. Build your muscle mass. Lift weights. It doesn't have to be big dumbbells, right? You can just pick up bags of sand and walk around carrying them. Just do stuff. Pick stuff up. We know that if we increase fiber in our diet, it's going to help. And we also want to eat foods that are low on what's called the glycemic index, which is coming up in the nutrition lecture, but you want to avoid foods that might spike your blood glucose. And a lot of times you might want to make sure you always eat protein with your carbs to kind of slow it down. But metabolic syndrome increases heart disease, diabetes, type 2, and strokes. And so you have a large belly. We know that if you have more belly fat, that belly fat actually makes hormones. It makes cortisol. So then you get more and more in the cycle because you get more belly fat. It's very difficult to lose. And then it starts producing more cortisol and you get into the cycle. We know that blood pressure going up could be a sign of this. Your blood triglyceride levels, if they're elevated, it's a sign of metabolic syndrome. HDL is your good cholesterol, if that's too low, and if your blood glucose levels are too high. So these are all like a cluster of conditions that are going to cause what's called metabolic syndrome, which you can imagine is the rise right now. And then just as far as body temperature, when we're warmer, our appetite goes down. So if you have a fever, you probably don't have an appetite. In the summer, you probably eat less. When our body temperature, however, decreases, then that typically increases our appetite. So going into the winter, you might notice that you eat more. And then I'm not talking much about psychological, but it definitely plays a role in it. Whether you have a favorable or unfavorable body image will affect the types of foods you eat and when you eat, which can lead to eating disorders. And then we all might have comfort foods that sometimes, it's okay once in a while, but you probably don't want to do it every day. So this is just an overview of factors that affect appetite and maintaining a normal weight. But I hope it was interesting for you, and it's the end of this lecture.